Hello guys, welcome to our channel. This is Jason. The new Yoga Slim line has come to us. As you noticed, there's a new addition to this new Yoga Slim 7 Pro X14 called X Power. To give you the sheer power to create from anywhere, we made a series of solutions and wrapped it all up to name it X Power. When you have it on hand, you will find the logo on the back of the product. You can see this small logo, X Power. So what exactly does X Power do to take the performance to the next level? What makes it so special that we have to give it a special name? Let's dig into it. Product performance mainly comes from key components configuration, cooling capacity, and hardware-software tuning. What makes up X Power? We have top performance hardware, leading thermal design power, turbo matrix, and cutting-edge scenario tuning based on heterogeneous computing. Thermal design power refers to the power consumption under the maximum thermal capability. We'll have a detailed explanation in our next video. Today we will talk about the other three parts: how to make the system run faster, and the software applications operate more smoothly under given cooling solutions. First, top performance hardware. Yoga Slim 7 Pro X14 takes high-performance standard voltage CPU. Selected the top brand SSD to ensure top read and write speed. Also, it has a high energy density battery cell, still remaining 70% battery capacity after 1000 full charge and discharge cycles. This top hardware selection provides a solid basis for Yoga Slim 7 Pro X14 to have an extreme performance release. Next, the turbo matrix for CPU-GPU maximum performance. Simply put, we take an already top component and push its performance to the limit by overclocking to make it run faster. With extreme CPU-GPU single brain, we made the utmost performance tuning for GPU VRAM overclocking. GPU overclocking gets from the 1.45G to 1.6G. VRAM overclocking reaches from 5.4G to 5.7G. It also supports CPU and GPU dynamic power control, so it can allocate power consumption adaptively based on user scenarios. For example, when playing games, the CPU will transfer power to GPU, while in office use, GPU will transfer power to CPU to ensure the optimal overall performance and at the same time stay cooling as always. Not only that, we have dynamic display switching and SSD direct connection technology to shorten the overall system data flow path. As you know, Intel Alder Lake memory controller just support 5200 Mbps as maximum speed. After professional simulation, layout, tuning, and verification, we made memory overclocking from 5200 Mbps to 6000 Mbps. Memory read and write bandwidth increased by 10 to 13%. This is absolutely industry-leading breakthrough. And finally, heterogeneous computing. This is a part I want to emphasize. The first two parts has been done on some good gaming laptops, but this heterogeneous computing is our first build. Before heterogeneous computing, it was all general-purpose computing, with graphics handling video and display, CPU doing everything else. Now that the generation is gone, in the future there will be more dedicated computing units that help CPU perform certain tasks and save more power efficiently. Heterogeneous computing can also be called hybrid computing. Similar to hybrid cars, the internal combustion engine is more responsible for medium and high-speed uniform cruising. The peak torque of the motor comes quickly, and more work in the starting and accelerating stages. Of course, the internal combustion engine and the motor can also work together to provide the maximum power for rapid acceleration. The CPU is like the internal combustion engine and the dedicated computing unit is like the motor. Of course, there are a lot of computing units in laptops. CPU is divided into performance core and efficient core, as well as graphics, media engine, audio DSP, and ISP. How to allocate and make good use of so many computing units and choose the most efficient computing units for different scenarios is quite tricky. This year, we worked with Intel, Microsoft, Adobe, and other mainstream hardware and software companies to optimize the performance and power consumption for office use, entertainment, content creation, and other scenarios. For example, CPU is most suitable for office work, receiving emails, video conferencing, and other scenarios. The Lenovo Smart Dispatcher will assign these light loading tasks to CPU efficiency core, which will reduce the power consumption more than 30%. When listening to music, CPU can do audio decoding, but it will consume more power, while Audio DSP do audio data stream with faster decoding speed and a tenth of the power consumption of CPU. As for video editing, thanks to software and hardware fine-tune, the media engine takes over some tasks supposed to be done by CPU and GPU. Video export speed up to 2 to 3 times. Media engine is dedicated for H.264 and H.265 video format decoding and encoding as hardware accelerator. It greatly improves the work efficiency of the video content creators. Yuga Slim 7 Pro X14 is the Lenovo first high-performance ultrabook to support X Power, not like the gaming laptop with the extreme cooling solution and absolute power release, but it has the best performance per watt, matching the best computing units to different user scenarios. A whole package with the best performance all the time and saving power as much as possible. Just like a hybrid car, acceleration performance and long mileage all in one. That's all for today's engineering insight. If you find this helpful, do feel free to leave your comments below. We are more than happy to discuss with you. Thank you all for watching this. This is Jason. See you next one.